Summary. The graph of the quadratic function has been presented in three ways. Each form has its own advantages and disadvantages. We have standard form, x-intercept form, and vertex form. If a question concerns the y-intercept, then the standard form is ideal. Clearly, the x-intercept and vertex forms, as their names suggest, make finding certain points a breeze. Exercise A. Given the quadratic function in standard form, f of x equals x squared minus 6x plus 3, write an equivalent in vertex form. Alright, so complete the square on the right-hand side. So we can complete the square just on this portion here. So we make space, and we divide 6 by 2, we get 3, and then we square it to make 9. So we're going to add 9, and then also subtract 9, so that the value of this entire expression doesn't actually change. Then we put these parentheses around this portion because we're just going to factor this portion and leave this part out. So then we factor, we get x minus 3 squared, and then we're going to have minus 6 here. And that's our new vertex form. So we have x minus h, which is 3, squared minus 6, and so negative 6 is our k. Exercise B. Given the quadratic function in standard form, f of x equals x squared plus 10x minus 4, write an equivalent in vertex form. Alright, so first we're going to complete the square on the right-hand side. So we have f of x equals x squared plus 10x plus something, we're going to figure out, minus 4, and then plus that same, or minus that same something. So we're minus 4 minus whatever we add here. So in order to complete the square, we take this 10, we divide it by 2, and that gives us 5, and then we square that, we get 25. So we're going to add 25, and we're also immediately going to subtract 25 so that the expression does not actually change in value. Then we can group it like this and factor this portion. So we have x and x. So 5 and 5 will work. We have 5 like this. And then this part, negative 4 minus 25, gives us negative 29. So we have x plus 5 squared minus 29, giving us an h value of negative 5 and a k value of negative 29. Exercise C. Given the quadratic function in standard form, f of x equals x squared minus 12x minus 5, write an equivalent in vertex form. Alright, so we're going to complete the square on the right side. So we have x squared minus 12x. Then we are going to add something. Then we're going to subtract 5, and then we're going to subtract that same amount that we're adding in, so that the overall expression remains the same. So we take this 12, we divide it by 2, 6, and then square it. So 36. We're going to add 36 and subtract 36, and then we are going to regroup these together. Now we factor this portion. 6 and 6 will work, both negative, because this is negative. And then negative 5 minus 36 is going to give us negative 41. And so we have x minus 6 squared minus 41, giving us an h value of 6 and a k value of negative 41. Exercise D. Given the quadratic function in standard form, f of x equals 2x squared plus 16x plus 3, write an equivalent in vertex form. Alright, so now we have an a that's not 1, it's 2. And we see that same a value here. So we have f of x equals 2x squared plus 16x plus our mystery number plus 3, and then subtract another mystery number out of it so that the whole expression remains the same. So we're going to group like this, but let's take that 2 out front. So we have 2x squared plus 8x plus, completing the square number, plus 3 minus the same amount. So if we divide 8 by 2, we get 4. 4 squared gives us 16. However, we don't then subtract 16. We have to subtract 32 because we've actually added in 32. 2 times 16 is 32. So that's what we've added in, so we do have to subtract 32. Alright, so then we factor this, so we have x, and then that would be 4 plus 4 squared minus 29, giving us an h value of -4 and a k value of -29.